Solubility and the Rate of Dissolving by Tommy, Iman, Cameron, and June.
Solutions are formed when a solute dissolves in a solvent. Solubility is the maximum extent to which a solute dissolves in a solvent.
First of all, the types of IMFOA in the solute and solvent decides whether a solution process can happen at all. A general rule is that like dissolves like. If the two substances are dominated by the same types of IMFOA, they are miscible and will form a solution. When they have dissimilar types of IMFOA, they are either immiscible or have a very low solubility. For example, NaCl dissolves in water because it has ion dipole forces. Hexane, C6H14, is a nonpolar molecule, so it has a very low solubility in water. Different solutes have different solubility based on the strength of the solvent-solute IMFOAs that form.
Another factor affecting solubility is temperature. The higher the temperature, the higher the average kinetic energy of the molecules, which are able to break free from the intermolecular forces of attraction easier and form solvent-solute bonds. Therefore, the higher the temperature, the higher the solubility.
Pressure is another factor, but it is only significant with gases dissolving. This is described by Henry's law that states that at a given temperature, the solubility of a gas in a liquid is proportional to the partial pressure of the gas above the liquid, because the pressure prevents molecules from escaping as gases, and therefore more have solute-solvent interactions, and the substances have greater solubility. Therefore, for gases as the solute, the higher the pressure, the greater the solubility.
The rate of dissolving is the speed with which the solute dissolves in the solvent. The temperature affects the rate of dissolving. The higher the temperature, the higher the average kinetic energy of the molecules. Then, the intermolecular forces are more easily broken, and solvent-solute forces are easier to form. So, the process happens quicker. Therefore, the higher the temperature, the faster the rate of dissolving.
Agitation also affects the rate of dissolving. Agitation refers to stirring or movement by outside force. With more agitation, it is easier to break the intermolecular forces so that solute-solvent forces can form and the solute can dissolve. So, the greater the agitation, the faster the rate of dissolving. The surface area is another important factor. If there is a large chunk of a substance with a higher surface area, it takes longer to break it apart and dissolve the solute. Therefore, the greater the surface area, the slower the rate of dissolving.